Welcome to our channel Learning Math. In this video, we're going to solve an extra geometry practice which is very important for the final exam for grade 7. Now let's start together. Consider a circle C of center O and radius OA equals 4 cm. The perpendicular bisector of the segment OA cuts this circle at the points M and N. Draw the figure. Here first we should draw the radius which is 4 centimeter. Now we open the compass equal to this radius and we draw our circle. Sure, we should put first the names of the points OA, the length of the radius and the name of this circle C. Now in order to draw the perpendicular bisector of the segment OA, we should keep in mind that the perpendicular bisector is the perpendicular drawn through the midpoint. So we need to locate the midpoint of the segment OA. As you see in the figure, we locate this midpoint, sure, at 2 cm, the half of 4. Now we put our set square, the 90 degrees exactly at the midpoint, and the set square should be aligned to OA as you see in the figure. Now we can produce our perpendicular bisector. We put the ruler aligned to the drawn perpendicular in order to produce it exactly. As you see, after drawing it, it cuts the circle at the points M and N. Now we need to join MA, AN, and OM since they are asking us later about the triangles OMA and ONA. Now as you see, what's the nature of the triangles OMA and ONA? Then verify that OM is parallel to A, and this is very important. Well, actually before reading our questions, we should have analyzed the given. What about analyzing the given? We have perpendicular bisector, then we have exactly equidistant. Can't we say that MA equals MO equidistant? Something else. What about points on a circle? They are asking us, they are telling us that the perpendicular bisector cut the circle at M and N. Now can't we say that OM is a radius to this circle? Also, ON is a radius to this circle. We have another radius given OA. Then can't we say that OM equals OA equals ON radii of the same circle? They are also equal to 4 cm. Well, let's start by writing. So here we have MA equals MO equidistant. Also we have OM equals OA radii of the same circle. Can't we say then that the three sides are equal to each other? So this triangle is equilateral. Something else, what about triangle ONA? By the same strategy, we have NA equals NO equidistant. Also, we have ON equals OA radii of the same circle. But instead of writing all the steps again, we can directly say similarly, triangle OAN is equilateral. Well, before moving to the other part, we should analyze our proof. Why do we prove them equilateral? We need to conclude that they have angles equal to 60 degrees each. Then each angle in each of the two triangles will be equal to 60 degrees. Now they are asking us to prove that OM is parallel to AN. How to prove them? If you know something, we can either prove them parallel on the same line, perpendicular on the same line, or find alternating or corresponding angles. If you know something, we have a shape Z in the figure. Can't we say that MOA salient equals 60 degrees equal to OA and salient? Well, here we have them equal to 60 degrees each, then we can say that the lines OM and AN are parallel by alternating angles since they form for us a shape Z. Now let I be the symmetric of O with respect to A. Show that IM is perpendicular to OM. How to prove it? If you know something, we should first draw our symmetry. We produce OA by the same length. Since symmetry of O with respect to A, then we need to produce it from A. So we produce it by the same length, which is here 4 cm. Know something, here we need to join IM and IN since they are asking us about them later. Now look at it. Show that IM is perpendicular to OM. How to prove that IM is perpendicular to OM? We need to prove that this angle is 90 degrees. First, we should start analyzing our given. What did we draw in this part? We have drawn symmetry of O with respect to A. So we produce it by the same length. Now, can't we say that OA equals AI by symmetry. Something else. We have AM is equal to AO. Didn't we prove that triangle OMA is equilateral? Well, now can't we deduce that AM is equal to AI? So this triangle is isosceles. Why are we proving it? We have just proved that this angle is 60 degrees. The angle MAO 60 degrees, angle of equilateral triangle. Now what about its supplement here? The supplement MAI, isn't it 180 degrees minus 60 degrees? So it's 120 degrees. Well, triangle MAI is isosceles. Can't we say that the base angles here are equal to each other? So we can say that the angle AMI salient equals the angle MIA salient. These two angles are base angles. Well, how to calculate them? We have this angle is 120 degrees. The sum of angles in a triangle is 180 degrees. So what remains for both of them? 60 degrees. Since they are equal, each of them will be equal to 30 degrees. Well, something which is very important, we have just also proved that each of the two angles here are 60 degrees. Well, since here we have 60 degrees and 30 degrees, then what will be the value of the angle IMO? 60 plus 30, 90. So we can say that IM is perpendicular to MO. This is very important. Now show that triangles OMI and ONI are congruent and determine their homologous elements. How to prove them? Let's take the triangles OMI and ONI. What are we having in these two triangles? If you know something, we have OM equals ON radii of the same circle. Well, we have OM equals ON radii of the same circle. Also, we have MOI salient equals ION salient equals 60 degrees each. We have proved that. Well, something else, we have OI is a common side. Can't we say then that these triangles are congruent by side, angle, side? Well, what about the homologous elements? The homologous elements are the elements that we did not use in our proof. This is very important. If you know something, how many sides are there in a triangle? We have 3 sides. Well, how many sides did we use? 1, 2. What about the third side? Here we can say that IM equals IN as homologous sides. Well, something else which is very important. We have 3 angles in each triangle. We have just used one of them, 60 degrees. What about these 2 angles? Can't we say that they are homologous angles? So we can say that the angle MIO salient is equal to the angle NIO salient as homologous angles. Now what about the third one? We have here the angle M salient, which is IMO salient. It should be equal to the angle ONI salient, homologous angles. Since we have this one 90 degrees, we have just proved it, then this angle will be also 90 degrees. Now deduce that OI is the bisector of the angle MIN salient. How to prove it? This is very important. To deduce, we should use the previous part. In the previous part, we have proved them as homologous angles. Yes? Therefore, we can say that since the 2 angles are equal, then IO is the bisector of this angle. Thank you for watching. If you enjoyed this video, please like, share and subscribe.